Hello guys, in this video we are going to talk about a worksheet 10.1B level 2 plus. It's talking about circle theory, the angle in semicircle, which tells us that if we have a straight line which is a diameter from A to B, then any point on the semicircle, so if you have a point B, point P on a semicircle, it's gonna be a right angle. So for example, if we get a point here and they still connect them from A to B, then this angle is going to be 90 degrees as well. So we still have a converse of the angle in semicircle, which means that if we have an angle 90 degrees, then we can say that the 2 points joining them is going to be the diameter. So that's the two theories we learned in this worksheet. So let's do the question 1 together. So first of all, in the figure, we have AB is parallel to OC. So we have the AB is parallel to OC, and we have the ODB is equal to 35 degrees. And also what we want to find out is the angle OAC. So OAC is actually here, isn't it? So this blue angle is going to be the angle that we want to find it out. So first of all, can we find out where is the 90 degrees, or where is our semicircle, or where is our diameter? So first of all, you can see that there's the center O, and you can see from A passing through O all the way to D is our diameter. And then we can draw our semicircle here, isn't it? So now we're starting from the point D and the point A. Is there any two common points is linked about this A and D, which is going to be our point B, isn't it? So now we can say that the angle B is going to be 90 degrees. So we can say the angle B is going to be 90 degrees. So we write it down first. So we have the angle ABD. So the angle ABD is equal to 90 degrees. And the reason for that is the angle in semicircle. So after we got this 90 degrees, what's the next step we can do? So if we say this is equal to 90 degrees, then in this triangle ABD, you can find out the angle of BAO, isn't it? Because the angle sum of triangles tells us that this angle plus the right angle and the 35 degrees will give you 180 degrees. So now we can say that the angle BAD plus the 90 degrees plus the 35 degree is going to be equal to 180 degrees. The reason for that is the angle sum of triangle ABD. So now we can say that the angle BAD is going to be equal to 180 minus 90 minus 35, give you 55 degree. So now we can say the whole angle here is going to be 55 degrees. So now, as we just want to find out what's the angle size of the blue part, which means that if we can find out the small parts like the angle BAC, then we can know that where is the angle of the blue part. So how can we do the rest? So first of all, if we take about this is OA and this is OC, so OA is actually equal to OC because they are the radii. So we can write it down, the OA is equal to OC, which are the radii. Then we can say that the triangle OAC is actually an isosceles triangle. So that we have the triangle OAC is an isosceles triangle. Then we can say that our required angle is actually equal to ACO as well. So we can say this angle ACO is actually equal to the required angle as well. So we can write it down, the angle OAC is equal to the angle OCA, which is the reason for that is the base angles isosceles triangles of the OCA. So now we can say these two angles are actually the same. So what's the other thing we can do? Because this angle is actually equal to this small part angle as well. What's the reason? The reason is these two lines are parallel, isn't it? So we can get a alternate angle, is it? So this is the alternate angle. So we can write it down. The angle of BAC is actually equal to the angle of BAC is this part. So BAC is actually equal to the angle ACO. The reason for that is the alternate angles, and we have the AB is parallel to OC. So now we can say that both of these two angles are a required angle, this BAC and ACO. Sorry. So the angle, the BAC, is actually the required angle as well. So we can say that the two angle OAC is equal to 55 degrees, so that we have the one angle OAC is going to be equal to 55 degrees. So that's for the question 1. So in question 2, well, how can we do it? So first of all, we have AOB and ODE are the diameters of the circles. So when you see the question is saying that's a diameter, which means that properly can find 90 degrees in the semicircle. So let's find it out first. So we have the straight line AOB is our diameter. So let's find in this semicircle. So in this semicircle, can we find the 90 degrees here? So is there a point on the circumference which is linked the A points and B point as well? So you can see that A is pointed to this point C, together with the B is pointed to this point C as well. So this point is on the semicircle, which means that this angle is going to be 90 degrees. So first of all, you need to locate this part. This is equal to 90 degrees. And if we look at the diameter DOE, and we look at the circumference, the semicircle here, is there a point that linked form the D and E? You can see the E is linked to the point A, and this D is linked to A as well, and this point A is actually on the circumference, so this angle is going to be 90 degrees as well. So we can say that this angle is 90 degrees. So first of all, we can write it down. The angle DAE is going to be equal to the angle ACB, which is equal to 90 degrees. And the reason for that is the angle in the semicircle. So if we have this angle DAE is equal to 90 degrees, and we have the part of it is equal to 45 degrees, which means that the rest part is equal to 45 degrees as well. So we can change this one to be 45 degrees. So we can say that the angle BAE, isn't it? So angle BAE is actually equal to the 90 degrees minus the 45 degrees, give you 45 degrees. So now we have this angle is equal to 45 degrees. So if now to consider about the triangle ABC, the required angle is the angle CAE, which is this small part. So we try to highlight it first. So this part is going to be our required angle. So if we consider about the triangle ABC, so we now have this is 45, this is 90, this is what we want, which means that if we understand what's the exact angle for angle B, then we can actually using the angle sum of triangle to find out the required angle, isn't it? So now we want to find out what's the angle B. So if you want to find the angle B, if you look at the triangle OBF and extend OF to E, you can see this 118 is actually exterior angle. And if we want to find out this angle, what it means that is need to have this angle as well. So now we need to find out what is the angle here. So this angle is actually equal to the opposite angle DOA, isn't it? So these two angles, this angle OBF is actually the same as the angle DOA. So which means that if we want to find out this, actually find out this angle, then it's fine. So now, if you want to find out this angle, if we locate it in the triangle DOA, you can see that we have this 45 degrees. If you want to find this out, you need to find out this ADO as well. So which means that if we can find out ADO, then we can find out the DOA as well. So how can we find out the angle ADO? As if we find out ADO, we can use the angle sum of triangle where we got the angle ADO. Then we can find out the angle DOA by using the angle sum of triangle. And then by using the opposite angle, we can find out this BOF. And then by using the exterior angle, we can find out the angle of B. And then by using the angle sum of triangle again, we can find out our required angle. So just step by step, and you understand the storyline, what does look like. So once we find out this angle, and all of the angles can be found, include our required angle. Okay, so let's see, in this triangle, DAO, is there anything that we know already? You see this point O is our center. So point O linked to A, this is the radius. The point O is linked to D as well, so that's the radius as well. So this two length is actually the same size because we have the OD is equal to OA. So you can first write down OA equal to OD, which is the radii. So now we can say that the triangle OAD is an isosceles triangle. So now we can say these two angles are actually the base angles. So we have the angle ADO is equal to the angle DAO is equal to 45 degrees. The reason for that is the base angles isosceles triangle. So now we find out the angle ADO is 45 degrees. So now we can using the angle sum of triangle to find out the angle O. It's gonna be using the, so we have the angle DOA is equal to 180 degrees minus 45 will give you a right angle 90 degrees. So the reason is the angle sum of triangle AOD. So now we find out this angle DOA is actually a right angle. So same for this angle BOF is a right angle as well, because we can using the opposite angles. So we have the angle BOF is equal to 90 degrees as well, because that's the opposite angle. And now we can say that these two angles adding together will give you this 118 by using the exterior angle. So we have the angle BOF plus the angle OBF is going to be equal to 118 degrees. So that's the angle OBF is equal to 118 degrees minus 90 degrees, which is give you 28 degrees. So now we have the FBO or the OBF is equal to 28 degrees. So the last step, we're looking at the triangle ABC. We got this is 28, this is 90, this is 45. Then you using the angle sum of triangle, then you can find out the rest angle. So that we have the angle CAE, the required angle, is going to be equal to 180 minus 90 minus 28 minus 45 degrees. And it's actually giving you 17 degrees. So congratulations if you got this is 17. So that is our required angle CAE. The reason for that is the angle sum of triangle ABC. So that's for question 2. So now we can do our question 3. So question 3, bear in mind the question is asking you to determine whether AC is the diameter of the circle. So now AC is not the diameter. We can't say that's the angle in the semicircle. It is 90 degrees. So actually we need to use the converse of the angle in the semicircle, which means that we have to show there's a right angle on the semicircle. Then we can say that the AC is the diameter. So let's see how to do it. So first of all, in the figure, we have that the AD is parallel to BC. AD parallel to BC. So we have the DFC, AEC, FEB are the straight lines. So AC and these two lines, these four lines are the straight lines. So it seems like that AC is really at the middle, but as now we don't have any condition saying that this is the diameter, and you can see from the question you're asking it to prove it. So which means that you can't use the AC as a diameter to prove this angle ADC is 90 degrees. But in converse, you have to using to prove that, to showing that the ADC is 90 degrees, then you can prove that the AC is the diameter. So our ultimate goal is to prove that the angle ADC is actually 90 degrees. So first of all, let's see how to do it. So if we have the angle CAD is equal to 50 degrees, here is 50, and we have angle AEB is 80 degrees. So this part is 80, And now we have the angle CFE is equal to the twice of the angle CBE. So you can see CFE. So this is going to be our CFE, and our CBE is going to be here, CBE. So this is going to be our B. So this is gonna be our CFE. So if we let this one be X, then which means that angle CFE is going to be 2X. So we can say that the angle CBE is going to be X, so that the angle CFE, this is going to be angle CFE, is going to be 2X. So is there anything else we can do with? So first of all, we can think about, because there is a parallel line and there is a straight line crossing them, then we can say this 50 degrees is actually same as here, as 50 degrees, because that's the alternating angle, isn't it? So we can say that this is actually equal to 50 as well. So for the first step, we write it down. We can say that the angle ACB is equal to the angle DAC, which is equal to 50 degrees, because the alternating angles, and we have the AD is parallel to BC. So that's the first part we can do. And if you look carefully at this one, at this triangle, and this line is make it longer, then we can say these two angles plus together is going to be equal to this exterior angle. So now we can say that's the 50 degrees plus the x is going to be equal to 80 degrees by using the exterior angles of the triangle EBC. So I say again, because we have this triangle EBC, so this is our two angles, and this 80 is going to be our exterior angle. Okay, so now we can solve it for the x is equal to 30 degrees, and as we have the CFB or the CFE is actually 2x, so we can say that the angle CFE is equal to 60 degrees. Then we can change the x to be 60, can change the x to be 30. So now we have this is equal to 60, this is equal to 30. So is there anything else we can do with? So if we want to prove that this is equal to 90 degrees, is there anything else we can do? So if we want to prove this is 90 degrees, it's actually the same thing if proving the interior angle is 90 degrees as well, because if two of them plus together should be equal to 90 degrees. So let's try to prove that this part is going to be 90 degrees as well. So let's see, if we want to prove that the whole thing is 90 degrees, which means I will still need this small part. So as this is 80 degrees, means that the opposite of it is going to be 80 degrees as well. So we can write down the angle FEC is equal to 80 degrees, and the reason is going to be the opposite angle. So this part is going to be 80. Then we can use our angle sum of triangle to find it out. So that the angle of FCE is going to be equal to 180 minus 60 minus 80 will give you this is equal to 40 degrees. By using the angle sum of triangle FEC, so that's the angle of FCB. So FCB is here. FCB is actually equal to the FCE plus ECB, isn't it? So you can using the 40 plus the 50 will give you 90 degrees. So we can say that the angle ADC is equal to 90 degrees as well by using the interior angles, and we have the AD is parallel to BC, and so that's the AC is the diameter. And by using the reason is the converse of angle in semicircle. So that's it. That's for question 3. So now we're moving to question 4. It's actually very easy if you look at it carefully. Okay, so first of all, we have the AOC as the diameter. So that's the angle at the semicircle, which is the angle ABC is actually 90 degrees as well. So we write it down first. So we have the angle ABC is equal to 90 degrees by using the angle in semicircle, so that we can say that the angle ABC is the right angles. So as OC is equal to OA, OC is actually equal to OA equal to 10 cm because they are the radius. So the AO is actually equal to 10 cm as well. So now we can say this is equal to, this is a right angle triangle. Then now we can find it out. What is the theta here? If we draw it out, the triangle ABC, if this is the theta, then the AC length is going to be 20, and the BC length total is 16. So we can find a relationship, the trigonometry relationship between these two lines. Then we can say this is the cos theta is equal to the adjacent divided by the hypotenuse. So the adjacent length is going to be 16 divided by 20, and you simplify it, will give you 4/5. You don't need to calculate the exact angle of theta, because what we want is just the length of DC. So if you consider about the triangle OCD, so consider the triangle of OCD, we draw it out. So this is going to be our OCD. So OC is going to be 10 cm. And we have the OD that we don't know. And what we want to find is the length of DC. So our angle OCD is this. So angle OCD is going to be theta. So as again, we can use in the cosine theta, it's going to be equal to the adjacent divided by the hypotenuse. So this is actually equal to the 10 divided by the hypotenuse, so which is CD. So hypotenuse side now this time is CD, so that we have the CD is equal to 10 divided by cosine theta, where cosine theta is actually 4/5. So this is equal to 10/4/5, and using your calculator will give you 12.5 cm. So isn't it very easy? If you understand the concept of cosine theta, then it's actually easy. So you can see the circle theorem is not only using the theory that you learned before, you can actually combine with the other trigonometry identities or some trigonometry stuffs as well. So the last part, we have question 5. So in the figure, we have the AC is perpendicular to BD. So where is AC? So this is AC, which is passed through O, and we have the BD as well. So these two lines are perpendicular. So perpendicular means that the DEC is going to be 90 degrees, so do the other three angles is going to be 90 degrees as well. So then we can say that the BD cut AC at E, so this is point E, and let the angle ACD is equal to D. So as the AC passed through the origin, so that we can say that the AC is the diameter, then we can say the angle ABC is the right angle. So this is going to be right angle as well. So now the question is asking you to express the ODE in terms of x. So where is ODE? So ODE is here. So after that, if AB is perpendicular to DO, and then now we need to find out what's the value of D. So how can you find it out? So what we want is to find out ODE in terms of D. So what's the method that we can use to find it out? So first of all, we can write down the angle ABC is equal to 90 degrees. And the reason for that is angle in semicircle. So after that, is there anything that you can realize? So for example, the OD is the OD is the radius, and so do OA is the radius. So if you connected O and B, that's the radius as well. And so do this OC. This OC is the radius as well. So we have OD, OA, OB, OC. All of them are the radius. So we can write down OA equal to OB equal to OC equal to OD. Both of them are radii. So you have the radii, then we can say that this angle OBC is x. So is there anything else that we can realize? So if this is x, then this is going to be 2x. So if this part is going to be 2x, then this, as the triangle ODB is the isosceles triangle, so that the angle DOA is 2x as well. And we can say that these two angles are the same, which means that these two angles are the same as well. Then we can using the angle sum of triangle to finish it. So that's just some rough ideas. So we need to change it back to the proof stuff. So now we can say that the OB is equal to OC, so that the triangle OBC, which is the isosceles triangle, so we say that the triangle OBC is the isosceles triangle. Then we can say that the angle OBC is equal to x. And the reason for that is the base angles isosceles triangle. And after that, we can using our exterior angle to say that's the angle, BOD, BOA. So angle BOA is here, BOA here. So angle BOA is equal to x plus x, give you 2x, and by using the exterior angles of the triangle BOC, so now we get this angle is going to be 2x. So after that, we can say that because this is the right angle, then we can say this is equal to 90 minus 2x. So as the angle BEO is equal to 90 degrees. The reason for that is AC perpendicular to BD. So now we can say that the angle EBO is going to be equal to 90 minus 2x. This one will give you just 90 minus 2x in terms of x. The reason for that is the angle sum of triangle BEO. So if you look carefully, this is the right angle triangle. So 180 minus 90 give you 90, minus more this 2x will give you the angle here. So if you look at the triangle OBD, then these two angles are the same, because they are asking about what is the the angle of the ODE. So we can say that the angle ODE is equal to the angle EBO. The reason for that is the basis angles isosceles triangle. So that's for question A. So now if we say that the AB is perpendicular to DO, then is there anything else we can do with? It's equal to 90 minus 2x. So if you see that these two lines are perpendicular, then which means that we have this angle is equal to this angle as well. So which means that this angle is going to be 90 minus 2x as well. So if I write here, so now we can say for part B, we have the angle ABE is equal to 90 minus 2x as well. I say it again because if you write like a Z, this angle and this angle are the alternating angle, because our ODE, what we find here is 90 minus 2x. So this one is going to be 90 minus 2x as well. So we can say the reason for that is the alternating angle, and AB is parallel to DO. So if you look carefully, this is equal to 90 degrees, isn't it? So this part is 90 minus 2x, this part is 90 minus 2x, this part is x. So as the angle ABC is equal to 90 degrees, so that we have the 90 minus 2x plus 90 minus 2x plus x. So again, the first 90 plus 2x is the angle ABE, as we find it here. The second angle EBO is equal to 90 plus minus 2x as well, as we find it here. So the third x is just this part. We find it in the first byte. So we can just plus these three bytes together to get 90 degrees. So now we can say that the 180 minus 4x plus x minus 3x will give you 90 degrees, so that the x is actually equal to 30 degrees. So that's for the question 5. It's quite hard to think about it. So I've give you my idea of how to do this worksheet. So if you find it really hard, then try to follow my steps to write it down, to understand each step, the reason for I write all of the steps. So this takes some time to understand it, but once you understand, in your exam it will be much more easier. Okay, so if you have any question, don't hesitate to ask me. Thank you.